All right, we are rolling now. We are now in Unit 1, Lesson 2, and we're going to be talking about square roots and cube roots in this lesson. Let's take a look at what we already know about square roots and our cube roots. One thing we probably already know is that there's a connection between squares, perfect squares, and square roots. So let's learn about the proper notation for square roots. Okay, let's read this word problem here. Okay, it says in lesson 1 you learn about the properties of integer exponents. Now take a look at this problem. The length of each side of a square measures s inches long. We don't know how much it is, it's just s. Okay, and it's a square, so all four sides are the same. The area of the square is 49 inches squared. That means this whole blue part of the square is 49 inches squared. That's its measurement. This whole inside is 49 inches squared. What is the length of one side of the square? So all we want to know is what one of these sides is. So what we're going to do is we're going to use what we already know to answer this question, okay? So in letter A, it says, describe in words how to find the area of the square given that each side is s inches long. Letter B says, write a multiplication expression using the variable s to represent the area of the square. Question C says, write an expression using the variable s as an exponent to represent the area of the square. That means you have to write a variable and an exponent to represent how we found this. In letter D, we're going to write an equation setting our expression equal to the area of the square given in the problem. So we're going to figure out what's given to us and how we got letter C, the answer to letter C, and put it together in an equation. And then in letter E, we consider the factors of 49. Explain what the two sides of the equation have in common when you write each as a product of two factors, okay? So we're going to write that each of them can multiply by itself. S times S times S times S would give us this, right? So let's write down what our formula is. What do we have to do to find the area? Are correct if you said you had to multiply S times S. Now we write that out in letter B. You can write it with your dot in the middle, you can write it with a multiplication sign, you can write it with parentheses. Now we're going to, since we're multiplying these together, we're going to write it in an exponent form. Since S and S are the same, I'm going to square it. So my equation is s to the second power. Now I'm going to take this s to the second power and I'm going to make it equal to 49. And now I'm just going to explain what the two sides of the equation have in common. This equation can be written like this, or it can be written as 49 equals 7 times 7. And that's how we solve our problem. We multiplied 7 times 7 to equal 49. Take a look at this table of perfect squares. Memorizing these squares will make working problems with squares a lot faster and a lot easier over the next couple of years. We're going to be learning a lot of this in algebra. So one main thing that I want you to do is make sure you memorize those perfect squares. That's what this table is called. It's the table of perfect squares. Now when we do an inverse operation, we're using addition as an inverse operation to subtraction, and vice versa. We can subtract and use the inverse operation to add. Same goes with multiplication and division. They're inverse operations. You can use one operation to undo the other. So let's go over some examples. Perfect squares have square roots. That's the inverse operation of squaring a number, is finding its square root. And the symbol for a square root is kind of like this check mark here. And we put our number underneath it of our perfect square. So these numbers here, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. Those numbers are our perfect squares. We put the perfect squares under our square root, and when we do an inverse operation and find the square root of 9, we look for our perfect square on the table, and we see that when we square that number, it equals 2. It equals 3. Take a look at number 49, our perfect square down here. Okay? So when we solve our equation, we have s squared equals 49, just like in our problem up here. Okay? Our 49 was the area of the square. So I said s squared equals 49. I'm going to find the square root of 49. It's positive or negative in the front means that this 49 could be a positive or could be a negative. If there's a positive and negative here, it most likely is a positive. 49 is that perfect square, so 7 times 7 would be the square root. So s would equal 7. So one of these sides would equal 7. So let's reflect. What's the difference between dividing 16 by 2 and finding the square root of 16? Think about that. If you said that division is making equal groups from one group, you're right. A group of 16 can be organized into 2 groups with 8 in each group. Thus, we have 16 divided by 2 equals 8. Finding the square root is finding what number is multiplied by itself. The square root of 16, as we see up here, is 4, because 4 squared equals 16. Negative 4 times negative 4 also equals 16.